Experiments is experiment number 3, physical and chemical chains. So log into your lab archives notebook and read the introduction first. The introduction will tell you the purpose and what you need to know to prepare for the lab quiz. The purpose of this lab is to observe some chemical and physical chains of several materials. So make sure you know the vocabularies to prepare for your lab quiz. You need to know the difference between physical and chemical properties and physical chains versus chemical chains. Make sure you know the difference between reactants and products. So for example, if I have substance A react with substance B, make two new substance, C and D for examples. So A and B are reactants. C and D is something have been made. Something formed after a chemical reaction has taken place are called the products. So C and D are the products. Precipitates is a form of the products. Physical states of matters. So we have learned from Unit 1 that three different types of physical states include solid, liquid, and gas. Distillation is a purified techniques used to distill water, remove the contamination in the water, in the liquid. Sublimation, condensation, condensate. So make sure you know all of these terms to prepare for your lab quiz. So the next properties of matters. Properties of matters include physical properties. So everything listed under here describes physical properties of a substance from orders all the way to the end of the list. Chemical properties include how the substance behave, react with other chemical substance. So for example, if some substance is very flammable, very reactive in the air, that describe chemical property of that substance. In general, physical properties describe how the substance look like, how it acts when it is around. Chemical properties it refer to how it behaves towards other substances. Physical chains. So make sure you know all of these terms describe physical chains. Physical chains includes how the solid change into the liquid and from a liquid change into the gas, or from a solid change directly to gas, or from gas change directly to the solid again. So make sure you know all of these terms and its definitions to prepare for your lab quiz. Chemical chains. So chemical chains occur when there are some chemical reaction have been taken place. There are 4 evidence indicate chemical reaction had been take place. So make sure you memorize these 4 evidence, 4 indicators to tell you that chemical chains have happened. The appearance of gas bubbles, that's the first one of the evidence or one of the indicators. The formation of a precipitate, change of color, liberation of heat or light. So make sure you memorize these 4 indications, 4 indicators to indicate chemical changes have been taken place. You're gonna see them again on the lab quiz. Energies and physical changes of states. So make sure you read this. Make sure you do experiment to understand the relationship between energies and physical changes. Distillation is the last technique you're gonna learn. It's a technique, it's a method used to purify a liquid from contaminations. Experiments. So make sure you watch the video and complete this short answers at the same time. So for example, so on your Canvas, make sure you click on the video link under modules, lab number 3. So you're gonna click on this one and load video in the new windows. So it's gonna walk to the videos which you need to watch to complete your answer for the lab experiments. Make sure you use the split screen techniques to answer and watch the video at the same time. Right. Okay, there you go. need to log into my lab archive again. 1 second. Okay, experiment. Okay, so I just applied the split screen. So the video from the lab and the lab I need to edit, fill out the answer on the right.
So today I'm going to show you the demonstration of a chemical reaction, that is burning of magnesium. So here I have a strip of magnesium which is
the first one is burning a magnesium ribbon. So you're gonna observe what happened
the
in
magnesium ribbon. So this is the magnesium ribbon, and this is Bunsen's burner and a watch glass in which I'm going to collect the magnesium oxide, which is white in color. These are the pair of tongs. So when magnesium reacts with oxygen, it requires heat energy, and after initiating this reaction, you will see that the magnesium burns in presence of oxygen to form magnesium oxide, and magnesium burns.
So in this case, magnesium and oxygen are reactants, and magnesium oxide, MgO over here, is the products. Okay.
Burns in oxygen with a brilliant white flame, that is called a dazzling white flame. Very difficult to see that. So let's try the experiment, and here I'm going to hold this magnesium ribbon. Actually, we don't require a very big piece of magnesium. It's very handy. You can even break it with your own hands. So I choose to put all other things aside.
So you're gonna see the.
As you can see that magnesium burns with a dazzling white flame.
Okay. So the observation is magnesium burn under the white flame. So make sure you put it in blue color. This one. Magnesium burn under produce or anything. White or bright flame. Okay. Is this chemical or physical change? So you pick one. So basically, um, you see magnesium burn in oxygen and it changed the color. It produced the flame. So that's one of the indication or one of the evidence to show the chemical reaction has been take place. Remember, there are 4 evidence you have to memorize: the formation of the bubbles, the formation of the precipitate, the change of color, liberation of heat or light. So in this case, the fourth indication, the productions, the produce, the liberation of heat, which is the flame, and the light. So it indicates this is a chemical reaction. So to tell chemical reaction or physical, to tell the chemical change or physical change, make sure you have to memorize 4 of the evidence. Some of reaction have 4 evidence, some of reaction is only have 1 evidence. As long as it have one of those 4 evidence, and then you can conclude that that is a chemical change. So the formation of bubble or gas, the formation of precipitate, the change of color, or the liberation of heat or light. So you're gonna do the same thing for strike a match. So you're gonna watch the videos and then to complete your observation and decide is it chemical or physical change. So if you watch this video, you should be complete all of this mini questions. So let's save it. Okay, the next one, change in physical states of matter. So you're gonna watch this video and you're gonna fill out this table at the same time. You're gonna observe and then record the time and the temperature in this table provided over here. So let me remove this. Okay, so when you watch this, you can watch and complete the table at the same time.
Hi grade 10s, I'm John McBride.
And I'm Joyce Pogo. Today we'll measure the temperature of water as it melts and is heated to its boiling point. We'll also measure the temperature of water as it cools.
Using this data, we will plot graphs of temperature against time. First for...
So I'm use the split screen again to watch the videos and then to record the data in the table at the same time. So if you this video is kind of long, so I'm gonna forward it. I show you how to record.
If it goes too fast, you can always rewind the video, or you can pause.
Celsius. The phase is still solid stroke liquid.
Now we wait for the rest of the minute.
So for example, at the first minute number 1, the temperature was measured at 0 degrees Celsius, and then I'm gonna record. After second minute, a minute later, the temperature is still the same 0 degrees Celsius. And now I try to add another rod after the second rod. So you have to hit the tap. That keep going. So you so now you need to watch it and then record.
The temperature is
set of readings.
5 minutes. Write it.
So I can record 5 minutes. I don't have to record 1, 2, or 3, or 4, and so on. You don't have to draw the graph. You only need to record in tables. So basically, make sure you record at least 10 of the data. Doesn't matter for minutes 1 to minutes 18. Make sure you have 10 of them. So after 5 minutes, for example, in this case, I just stop. And the temperature, make sure you know how to read the thermometers. So the thermometer here is tell this is 0 and this is number 10. So this is about 5 degrees Celsius. So I put number 5. So at 5 minutes, it's 5 degrees Celsius. Let's try another one.
Down for yourself, learners. This is what the beaker looks like at 5 minutes. This is the thermometer reading at 6 minutes. Write it down.
So you can pause it, and then now you're gonna read again. So at 6 minutes, the temperature, according to the thermometer, is about 7 degrees Celsius. So you're gonna do the same for 10 or 18 minutes. Make sure you count 10 of the rows here, and then you complete. Then you're gonna answer some of these short questions. At the temperature of liquid water thawed, heat energy is passed from the liquid to the solid water, which is the ice. What happened to the ice as a result? So the ice wanna go what? The ice is obviously you can see it melting, right? Is it more dense solid or liquid water? So the first question, the ice is melted, and the second question is which one is more dense? Solid water, which is ice, or liquid water? So according to the beaker, you're gonna see here the ices always float on top of the water, which is water is more dense than solid water or ice, or solid water, which is ice, less dense than water, than liquid water. What is your evidence for this? So obviously you observe it from the beaker. Gas to liquid. So now you need to get a glass of ice water and wait 5 minutes. Notice the liquid would collect from the outside of the glass of ice and water. What is common name of liquid substance? So the liquid condensed outside of the class is the liquid substance is water. So the liquid condensed outside of the class is water. Where it's coming from? So you get a cup of water, you leave it on the table. After a while, you see the wall of the glass from outside start sweating, so it start getting wet because it has the moisture in the air condensed to the glass. So it comes from the air or the atmosphere or from your room. So that is where the water coming from. It's not leaking from the inside out. It actually the condensation of the moisture in the atmosphere and it condense into the glass. Write the name of the process that result the formation of the liquid outside of the beaker or outside of the glass. The name of this process is in the air is in the gas and it condenses into the liquid. So that process is called condensation. So make sure you review all the six process: physical state change, vaporization, condensation, freezing, melting. So all of that, freezing, to be able to answer for these questions. Solid to gas. So solid to gas. This process is called sublimation. So you're gonna watch the videos, save this, and load the video. Sublimation. So this, which is this one. So you can load it to the another videos. So basically, this iodide is the solid. So after they heat it, it turns into the iodide. They heat it, it's gonna turn into the purple vapor. So that's process changing from the solid to gases, which is the sublimation. Do you see evidence of the melt iodide? So basically, iodide is not melted, it's not turned into the liquid. It goes directly from the solid to gas. So there's no melting. It's not turned into liquid. You don't see any liquid at all. It goes directly from solid to vapor iodide gases. The purple, the purple vapor that you see is iodide. Get the name of the process. So something changed directly from the solid to gases we call sublimation. So make sure you review that. Why doesn't the iodide vapor come out of the test tube and react with the air? So basically, it's not very reactive to the oxygen, so that's why it not react in the air. Liquid to gas distillation. So in this one, you're gonna learn the techniques. You're gonna see the setup of distillations. So the chemical, the contamination, the mixture they have is copper sulfate dissolved in water. It given the water have a light blue colors. So this color from the beaker because there is a copper 2 sulfate dissolved in water. So they set up the distillation to heat these mixtures, and the water is going to be vapor turned into the gas, and it's going to condense into the tube, and then they can purify the pure water again. So make sure you watch this. And what color of the copper sulfate solution in the flask? Basically, the blue color coming from the copper sulfate solution. So it's blue color, very obvious. Make sure you answer for that. What color of the condensation in the test tubes? So water after it condenses is the pure water. So most of all pure water should have the colorless. It's no more blue, which is it no more contain the copper 2 sulfate after it had been distilled. What is the distillation? So according to your introduction, distillation is a technique to purify the liquid, so on. And make sure you try this part. Google fat state of matters. So let's try this. So let's say we finished with this already. Then we're gonna Google fat state of matter. And then you click on the first link. So there is a simulation, it's gonna load for you, and then you're gonna learn different type of states: solid, liquid, and gases. And let's get back to your lab again. There you go. Right. Okay. So now you're gonna have both at the same time. Click on the first link. Click on the Run Now button. Explore the simulation. Be sure to click on everything. Right, two things you think the simulation is designed to help you learn. So there are two things it designed. You can control the heat. So if you increase the heat, you're gonna see the particle. For example, in this case, the solid particle is moving a little bit more, right, when it's cold. So when you cool down, your particle less moving compared with the heat. And let's try with gas particle. If you heat it, the particle is moving more faster, more speedy. When you cool it, the gas particle is slow down. So you're gonna see, if I heat it, you're gonna see the thermometer on top here is starting to increase in temperature. So Kelvin, K, which is Kelvin, the thermometers. You can try different type of gas, neon, argon, oxygen, or water. You also can try water. So for example, I have solid water, which is ice. I drop the temperature. All of this molecule is move a little bit slower, but they heat it. You see the vibration, they start moving more. So two things. The simulation is designed to help you learn that the effect of heat on the motion of the particles. So you're gonna observe three of this: the solid, the liquid, and the gases. So you're gonna compare what difference between solid, liquid, and gases. So as you can see, for example, let's pick the neon. When it gases, the distance between one particle to the other particle is very long. But when it's liquid, the distance a little bit more closer. But when it's solid, it's even closest. So the particle closest over here, closer in the liquid, and they a little bit have a distance when it's in the gas phase. So go to the second tab at the top of your screen, phase change. Be sure to watch what happens when the thermometer and pressure goes. Okay. Phase change, which is the second one at the bottom here, you can click it and move the arrow. So you can put more particle into it. Or you also can control the heat or energy. So if you see, if I increase the heat, the speed of particle, they moving faster, and the temperature is increasing, right? So at heat, you see the temperature is getting increasing, and the pressure is also increasing. When we remove the energy, so if I don't add the energy, so I remove it, leave it, and you're gonna see the pressure dropping and the temperature, the speed, it also slow down. So the temperature, if I let it cool long enough, you see the drop in temperature. So when we remove the energy, the temperature drop or decrease, the speed of particle it also decrease, and the pressure it also decrease. So figure that out. What happened to the speed of the molecules at heat will add it. So if we add heat it, the speed, everyone can see it, it's moving faster. So the speed is increased when we add heat. What happened when the arrangement of the molecules at heat will add it? So when we add heat, the arrangement is collapses. So they're just moving in all directions. Okay, so answer that question. So use the bicycle pump to add matter, so you can add more matter. So the more pump you add it, you're gonna see the temperature also increase and the pressure is also increased. So you can also press down to reduce the volume. So that's I reduce too much, so it expand. So return lid. If I press down, you see the pressure increasing and the temperature increase. So if I reduce the space, which is press it down, the finger down, the volume gets smaller, the temperature increasing, and the pressure is also increased. So write two things about your discover. So you discover that for the same amount of particles, the volume getting smaller, the temperature is getting increased, the pressure is getting also increased. And another discover is the more particles are, the more pressure and the also higher temperature. Okay, so that's pretty much for your simulation for the last part. And for your preparation of next lab, make sure you gather 3 water bottles and follow this instruction. And that's what you need to know for the next lab. Okay, good luck everyone. If you have questions, let me know. After you finish, you can ready to take the quiz. Make sure you review, take the quiz. Make sure you know the physical change versus chemical change. Make sure you know for evidence of chemical change, the formation of precipitate, formation of bubble gas, the change of color, and the liberation of heat or light. And other physical states of matters and other physical changes. Condensation, crystallization, melting, freezing, sublimation, so all of those. So make sure you review those for each physical for each change technical terms. Okay.